As we start to work on more complicated stoichiometry problems, where our given quantities are not already in grams or moles, we need to find a way to get to grams or moles so that we can resume a normal routine. The first step is to dream up a way to convert our starting materials to grams or moles. So let's read through the question. Octane has a density of 0.692 grams per milliliter. This first chunk of information tells me that I'm probably going to use my density to convert between mass and volume. I'll keep going. How many grams of carbon dioxide are produced when you burn 5 gallons of octane fuel in a combustion engine? Okay, well, I see now that my starting amount, or the chemical that I know a number about, is going to be that octane fuel. Okay, but gallons are not grams. So let's find a way to convert my gallons into grams. The first thing I'm going to do is I'm going to write down 5 gallons of octane. And then I'm going to look for a way to convert that gallons into something else. I see that my question has provided to me a really nice way of converting gallons into liters. So let's go ahead and do that. For every 1 gallon of this octane fuel, I'm going to have 3.785 liters. Supposedly that'll get me one step closer to grams or moles, but I'm going to need to brainstorm a little bit more. My density amount, 0.692 grams per milliliter, has milliliters in it. Those are related to liters in some way. You can say that 1 liter has 1,000 milliliters in it. Once I've converted my liters of octane fuel into milliliters, I can now use the density, 0.692 grams per milliliter of octane. And now I finally feel like I'm in a normal stoichiometry question. Now that my unit is in grams, this question returns to a standard stoichiometry routine. I have grams, go ahead and convert them to moles. I've already seen octane in a problem like this, so I know that my molar mass is 114.206 grams per mole. Now this is a great point to reread the question to focus in on what chemical we're trying to solve about. Right now I've got moles of octane. So I'll continue to reread the question. Octane has a density, blah, blah, blah. How many grams of carbon dioxide? Okay, so my next goal is to convert my moles of octane into moles of carbon dioxide, the goal molecule. I'm running out of room, so I'm going to continue my work down here. 1 mole C8H18, just kind of to remind myself that I left off at moles. And in my balanced chemical equation, I see that I have 2 moles of octane for every 16 moles of carbon dioxide. In this case, you can write down 2 moles of C8H18 for 16 moles of carbon dioxide. Now, some people feel the need to simplify this ratio right away, the 8-to-1. Since you guys are typing these into calculators, it's really unnecessary to simplify ratios at this moment. I like to keep them matching my stoichiometric ratios. That way I can always remember where the numbers come from. All right, now it's the last step. I need to answer the question. Now that I've got moles of my desired molecule, I need to see what I need to change those moles into. The question is asking us for grams of carbon dioxide. So I'm going to multiply my moles of carbon dioxide by the molar mass. 44.01 grams carbon dioxide for every 1 mole of carbon dioxide. Now is a great moment to hit that calculator. And we'll end up with some giant number of grams. I'm going to simplify down to 2 significant figures. We'll end up with 4.0 times 10 to the 4 grams of carbon dioxide. Again, the main problem-solving strategies in these complex questions are to find a way to use dimensional analysis to get our starting information into a useful unit like grams or moles. Once you're in grams or moles, you can use our regular stoichiometry to move to another mole of chemical and then to answer your question. In this next example, we're going to talk about how to handle percentages by mass. In several different stoichiometry examples that I've seen, we either have a tablet that is a portion of our interesting starting molecule, or they're asking how much of a tablet we could have at the end that would have the appropriate amount of chemical. Let's start with the first type of example. Let's go ahead and read this question. What is the maximum mass of phosphorus that can be produced from 1 kilogram of a mineral that is 75% calcium phosphate by mass? Okay, so since our mineral is only 75% of our interesting molecule that's part of our equation, we're actually starting with 1.0 kilograms times that 75%. I like to use decimals instead of percentages because that's just how I roll. So we really only have 0.75 kilograms of our starting material. That's the only difference between these percent questions and regular stoichiometry questions. Now all we need to do is set up our dimensional analysis. 0.75 kilograms of calcium phosphate. Now, these guys aren't grams, but it's not a huge leap to feel comfortable changing these kilograms into regular grams. In every kilogram, we have 1,000 grams. And now that we're in grams units, for our calcium phosphate, we feel comfortable converting these grams to moles, like in all the other stoichiometry problems. Okay, so we're going to need the molar mass. Molar mass of calcium phosphate is 310.08 grams per mole. Now is a great chance for us to reread the question. We're looking for the maximum mass of phosphorus. Okay, so we'll check out the mole-to-mole ratio from the balanced chemical equation. We have a 2 in front of our calcium phosphate, 2 moles calcium phosphate. And there is not a number in front of the phosphorus, so I'm going to assume that's a 1. And the last step, it's asking for mass. It doesn't tell us if we're going to do grams or kilograms, so I'm just going to make the executive decision to say that we are looking for grams. And multiply by the molar mass of phosphorus. This guy seems to have 4 phosphorus atoms in that phosphorus molecule, so I'm going to go ahead and multiply times 4 to get 123.88 grams. of phosphorus for every mole. We will do our fancy math and multiply in a calculator across the top and divide by each number on the bottom to get a final answer, which gives us 149.76. Looks like in our question we need to round down to 2 sig figs, so I'm going to say that this is 150 grams of P4. Make sure to practice all of these types of problems from your textbook with your Student Solutions manual handy.